Hello friends, welcome to Shiksharthi. In this session, we shall be discussing a right angle triangle, its properties and its applications including Pythagoras Theorem as well. So let's start. Now let me draw a right angle triangle first. Okay. Now if I say that this is a right angle triangle, in the very first place, if somebody says just by drawing, so you have three non-collinear points. Let's take these points as x, y and z. And just after drawing, somebody tells you that this is a right angle triangle. So for a learner, the counter question here would be, is it a right angle triangle? And the person who says that yes, this is a right angle triangle would be flawed here, because the right angle triangle is a triangle which is decided by the angle which two line segments which are intersecting with each other, and in this case those two line segments are xz and yz. They intersect at right angles. Since the diagram does not mention about any of the angle, any angle out of the three angles which exist here inside the triangle, we will not assume it to be a right angle triangle. This is the first point to be learnt here. Second, now if I say that this is right angle, so even if I do not write 90 degrees here, that doesn't make any difference, because this symbol itself symbolizes that this is a right angle triangle. So you are drawing a kind of an L which you are putting on the point Z in such a way that it looks to be either a square or a rectangle. I repeat, if I am putting or I am adjusting an L, the letter L of an English alphabet I am talking about, at the point Z in such a way that this figure, the enclosed figure that we can talk about, in which one of the points of that four-sided figure is Z. So this figure with this quadrilateral should either be a square or a rectangle. It is then only you will be able to say that this is a right angle triangle. This is the first point for a learner to learn. Thereafter, now the remaining two angles. So when we talk about x, angle x plus angle y, and if somebody tells me that there are three angles of a triangle such that angle x plus angle y is equal to 90 degrees, can I say it is a right angle triangle? Yes, I can. So for yes, I am denoting it by a green colored pen. Yes, I can say. Here I have used a blue colored pen. Okay. At the same time, if I say if one of the angles, let's say in this case, is equal to a 90 degrees, is it a right angle triangle? Yes. So here also I'll put a condition here. Let us say if is the condition that I have put here. Okay. Is there any other condition that I can put here so that I am able to certify that the triangle that I have drawn here, which is the triangle XYZ, is a right angle triangle? I don't think so that there is any other condition that we can put here except for the condition on the sides. So these are the two conditions that we can put for a right angle triangle to exist when it comes to angles. The third condition that we can put here is what is the relation between their sides, which will determine whether it is a right angle triangle or it is any other triangle. The relation between their sides. So here I am putting it as relation between the sides. Here I am referring to is xy, xz and yz, which will decide whether it is a right angle triangle or it is any other form of a triangle. So when we say any other form of a triangle, that we will talk about when we are talking about the applications. Okay, now As you would see that every session of geometry has a prerequisite. So here also the prerequisite is you should know about lines, angles and triangles. In addition to this, perpendicularity is what we are discussing here. Parallelism you need to know. You need to know the criterion for congruency and similarity. So this is one side of it, and we will see finally what is the relationship that can be established between the sides of a right angle triangle. For this I am just drawing a line here so that I can divide this discussion into two parts broadly. Okay, now going forth, let me draw a triangle here once again. So when I am drawing a triangle here, let me again draw a right angle triangle such that I have two right angle triangles by the side of each other. So here comes maybe one of the applications of a right angle triangle, wherein what we have done here is we have drawn two right angle triangles by the side of each other such that their perpendicular side is common between them. And let me take the common perpendicular side as capital P, the base of the first triangle as B1, the base of the second right angle triangle as B2, the hypotenuse of the first right angle triangle as H1, and the hypotenuse of the second right angle triangle as H2. Let me take their vertices as X, Y, Z and W. Now the thing that remains to be done here is, so now let me write down what have we assumed here. We have assumed that the angle XZY is the same as angle XZW is the same as angle YXW, and all of them are equal to 90 degrees. This is what we have assumed. Let's say this is what is given here. So in that case, if I take angle if I take angle as XYZ as X, so the angle YXZ becomes 90 minus X. YXW is already known as 90, so in that case 90 minus of 90 minus X would be X. In that case the angle XWZ becomes equal to 90 minus X. So now what is the outcome of this? The information that is given to you. Let us write down the outcomes here. So we are able to say that angle XYZ is the same as angle YXW, which is the same as X degrees. Analogously, we will be able to say that angle YXZ is the same as angle XWZ, which is equal to 90 minus X degrees, or 90 degrees minus X degrees. Right? Okay, going forth. Now let us see what are the things that we can use here so that this becomes really a very healthy discussion when we say that take your learnings to the next level. So taking it to the next level now, can we say that the triangle, now let me talk about the angles in this order. I mean, I'll talk about 90 degrees first, then X degrees, then 90 degrees minus X degrees. So can we say that the triangle Z followed by Y followed by x is similar to triangle. So again 90 is z followed by x followed by w. And which property are we using here? We are using AA test. And what is the outcome for this? Using BPT, you'll be able to say zy upon zx is the same as zx upon zw is the same as yx upon xw. Similarly, now going faster, can we say that the triangle ZYX is similar to the triangle, and why are we using? So we are keeping this triangle ZYX as a constant. So initially we compared one triangle on the left hand side, the right angle triangle, with the other triangle lying on the right hand side. Now we are comparing the left hand side triangle with the entire triangle XYW, in which case the angle x is 90 degrees followed by y, which is x degrees, followed by w, which is 90 minus x. Again you are using the AA test only, and then you will be able to say that using BPT you will be able to say that zy upon xy is the same as zx upon xw is the same as yx upon yw. So you get this, these sides are in proportion to each other. Analogously, or finally, using both these tests, we can conclude and compare the right hand sides. So when we are comparing their right hand sides, keeping their left hand side constant, that means we are using the concept of identities. So what are we saying? We are saying finally that the triangle ZXW is similar to triangle XYW using the AA test, which remains the same here, because of which you will be able to say that ZX upon XY is the same as ZW upon XW is the same as XW divided by YW. We'll be able to say this finally. Now let us treat them as three different equations, and we'll see that all these three equations, they give us some outputs. What are the outputs finally that we're going to get? Let's see, and we'll write it down below this line. Okay, so let us see what and where are the important parts. Let us write down the important parts first. For example, from equation 1, so we treated this as equation 1. From equation 1, if I pick up something, what is that something I would want to pick up? I would want to pick up these two fractions. So from here we'll be able to say that zx whole square is equal to zy into zw. What does this boil down to? This boils down to, in terms of sides, we have already assumed. So we are saying p whole square is equal to the product of the bases, right? Let us see the second one. So from here, now if I see this, let me pick up this and let me pick up this. From here we'll be able to say that xy whole square is equal to yz into yw, which is just like saying h1 square is equal to b1 into b1 plus b2. Right? Let's see what is the third conclusion that we can have from here. So the third conclusion that you can have from here is, can we say that xw whole square, that is from the third equation that we are having this conclusion, will be equal to wz into wy, which is just like saying h2 whole square will be equal to b2 into b1 plus b2. These are the three very important conclusions that we can have from those three equations that we had. So now let me term this as equation 4, this as equation 5, and let me term this as equation 6. And now let me see what is the final conclusion that we can have based on equation 4, equation 5 and equation 6. Now if I add, let us say I want to add, what should I add? So adding also needs some sense here. So can I say that if I add yz and zw together is just like saying if I add the triangles xyz and xzw, it is then only that I can think of getting the triangle xyw. So in that case, what should I add? I should add xy whole square with xw whole square, which is just like saying adding equation 5 and 6, which gives me basically, so you would see yw becomes common. Now this will be yw into yz plus yw, yz plus zw, which in any case becomes yw again, which is yw whole square. So which is the seventh conclusion that we get from here, which gives us the relation between the sides, which is just like saying xy whole square plus xw whole square, which is the sum of the squares of the sides, which is perpendicular square plus the base square, basically gives me the hypotenuse square, and the hypotenuse in this case is okay. So now please take this slightly different, I mean in order to understand that both these triangles are slightly different to each other, I am taking this as x dash, y dash and z dash. So x dash yz y dash whole square is equal to, plus y dash So x dash y dash whole square plus just so y dash z dash whole square should give me the hypotenuse square, which in this case is, and a small mistake here, instead of writing it as x dash y dash, we would want to write it as the perpendicular square. So this is what we finally get when we add the equations. Let us say we added equation 5 and 6 to get what we got as the 7th equation. Now once you have got this as a final byproduct, maybe what you can do is we know that the area of this triangle XYW is nothing but half into base into height, which is the same as half into base. So if I just change the orientation here, the orientation I'm referring to is, if I take the triangle YXW, I know that the angle X is also 90 degrees. In that case, we are saying that this is half into base, which is XW, into height, which is YX. Let's say this is the 8th conclusion that we get from this entire discussion, which comes as an application of a right angled triangle. Now finally, if I take this as the perpendicular, if I take this as the base and this as the hypotenuse, we have already established in point number 3 that for a right angled triangle, hypotenuse square is equal to the perpendicular square plus the base square. Now please try and understand that here, as point number 4, which is one of the applications of a right angled triangle only, if I increase this angle, I'm talking about angle Z dash, so we will have to take the side like this. This is how we would take the side. So in that case, the length of the so-called hypotenuse, because when you increase the angle from a 90 degrees to, let's say, 110 degrees or 100 degrees, in that case it becomes an obtuse angle triangle. So in that case, the length of the hypotenuse square will be greater than the square of the perpendicular and the square of the base when added together. This we are talking about for an obtuse OAT, obtuse angle triangle. And 5th point here is, when we would have decreased, when I decrease the angle Z, that means you are taking the angle Z towards the line segment Y dash Z dash. So in that case, you are decreasing the angle from a 90 degrees, let's say, to a 60 degrees, 75 degrees. In that case, the length of the hypotenuse would be decreased. So would be the square, and so on. So this is for an acute angle triangle. I repeat, as a final application, for an obtuse angle triangle, the length of the hypotenuse whole square will be greater than the square of the lengths of their perpendicular and the base. And in case of an acute angle triangle, the square of the length of the hypotenuse will be smaller or lesser than this length, the square of the length of the perpendicular added to the square of the length of the base. I hope you'll be able to assimilate all this and take your learnings to a new level.